Hi, and welcome to Data Ethics in AI. I'm really sorry I couldn't be there with you in person today, face to face, as this isn't a particularly light topic, I know. And so I thought that I would start off by just telling you a little story about a trip that I took during the COVID pandemic. Now, I have spent most of the last 10 years of my career traveling pretty extensively. And so when the pandemic hit and I was stuck in lockdown in the United States for an extended period of time, I was going a little bit stir crazy. And so I went on to a car auction site and bought a car in Kentucky. I live in Oregon when I'm in the United States. And I flew across the country and picked this car up and drove it back to Oregon, which was about a 2 to 3 day trip. And to make the trip more interesting on the way back, I decided that I would use this website called Atlas Obscura, which is a really cool site. If you haven't visited that site before, it's great for road trips because you can literally sort of plan out your trip according to very odd attractions, obscure attractions along the way. And so on my trip from Kentucky to Oregon, I stopped and saw the world's largest shuttlecock, which you can see in the upper left-hand corner of the screen. I saw the world's largest ball of sisal twine. I went to a replica of Stonehenge called Truckhenge, which is on the bottom right. So Stonehenge made out of abandoned trucks. And I visited the world's only barbecue vending machine. And then my last stop on the trip was to see my cousin Allison in Colorado, or Allie, as we call her in my family. And she just had a baby, so she hadn't been traveling much, even pre-pandemic, as you can imagine. But since we're both sort of world travelers, we were discussing our last international trips, and Allie started telling me about her most recent trip to Portugal, which was the last trip that she took before she had her baby. Now, this was also the first trip that she'd taken after getting married, and she'd recently changed her name. Her maiden name was Allison Tompkins, and she changed it to Allie, the shortened version of her name, which is what we all call her, and then her new last name, which is Padilla. Now, Allison had traveled a lot and never really been stopped by airport security before, so she was surprised when on this last trip that she took, her first trip with her new name, she was stopped over and over and over again. First in the US, then France, then Spain, then Portugal, and again when she landed back in the United States. And it took her months to really figure out why. Any idea what it was? What was the reason that she got stopped so many times? Well, it was a name change. Allie had become Ali suddenly. Tompkins became Padilla, no longer female, but male. No longer American, but of some suspicious heritage. Customs and Border Protection in the United States, if you're not aware, collects just a wealth of information on all the travelers that cross our borders, all of which is stored in this sort of master crossing record that the agency keeps on every individual who enters the United States. And that record contains information gathered at pretty much every crossing, the time, the date, the port of the crossing, the information taken from their travel documents, photos, data collected on their belongings in some cases, and determinations that are made by customs officers throughout the process for non-US citizens. This also means biometric data, such as photos and fingerprints. This is all stored. And that information is forwarded onto the automated biometric identification system, or IDENT, the Homeland Security Department's central biometric database, which currently contains data that I believe they have data now more than 250 million people. Under current authorities, Homeland Security can hold onto that biometric data for up to 75 years. So a pretty long time, as you can imagine. And that data is then mined and flags certain travelers based on specific criteria determined by authorities, thus leading my cousin Allison to be flagged over and over and over again as Ali. If you Google my cousin's full name, you can kind of see images of somebody named Ali versus Ali. And I think that that you understand then why she was getting stopped over and over again. Now, obviously, there's a lot of debate as to whether these types of systems for flagging potentially dangerous travelers are actually enforcing long-held and often incorrect stereotypes. But my cousin is a great example of how, as someone who isn't typically screened, many of us, myself included, take for granted how easy travel is because we've never experienced anything different. When the truth of the matter is that our reality isn't everyone's reality. And so I thought that I would spend a few minutes sort of level setting on unconscious or implicit bias, because that's where it really comes into play, you know, in situations like the ones my cousin Ali experienced. For the sake of ensuring we're all on the same page with how unconscious bias is generally defined, it's important to understand that it is unconscious. It's everywhere. It's not one single issue, but many small things that can lead to stereotyping and bias, as you can imagine. The good news is that we can actually learn to counter these biases once we become aware of them. And to give you an example, I have a riddle for you. So the riddle is, a father and son are in a horrible car crash that kills the dad. The son is rushed to the hospital, and just as he's about to go under the knife, the surgeon says, "I can't operate, that boy is my son." I'll give you a few seconds to think about it. Only about 14% of the original sample actually got this riddle right, if you can believe it. And if you're having a hard time figuring out what the answer is here, it's because the surgeon is female. So although the father was killed in the car crash, obviously the mother was still alive, and the mother is a surgeon. For a lot of folks, they miss that question because they're not thinking of women in the role of a surgeon. And so that riddle can be pretty complicated, but I think it's also a good test of unconscious bias. And if you didn't get the riddle right, it's a good opportunity to examine your own unconscious biases. Now you might think that obviously not getting the correct answer to the riddle is no big deal. I think until you fully understand the profound impact that unconscious bias plays on the health and wealth of so many people. And I'll give you a few examples. Cristina Criado-Perez, the author of this amazing book called Invisible Women, Data Bias in a World Designed for Men, tells the story of a little town in Sweden that decided to apply a gender lens to all of their policies. And one official joked that, you know, quote unquote, at least snow clearing was something the gender people would keep their noses out of. And that sort of got that committee thinking, is snow cleaning or snow clearing sexist? What's interesting is that subsequent analysis found that the administration's approach to clearing the streets was indeed sexist, prioritizing major traffic arteries rather than footpaths and cycling paths, which disadvantaged women because they disproportionately walk and use public transport. Women also tend to have more complicated travel patterns. They're dropping children off at school, taking a relative to the doctor, food shopping, than men whose main journey is a trip to and from work. It turns out, unfortunately for the official, that snow clearing was not actually gender neutral. You can kind of see the same bias in crash test dummies and testing on men. Women are actually nearly twice as likely as men to become trapped following a car crash. And there are actually significant differences in injury patterns. Now, why does that matter? Well, for a start, because patients who are trapped have worse outcomes than those who are not trapped. So designing cars so that women are less likely to become trapped would seem to be an important public health initiative. And let's not forget, we already know that women are 73% more likely to be seriously injured or die than a man in the same crash. You may not know that there's actually 3 test dummies for frontal crash tests. The first dummy is a 95th percentile male dummy, so only about 5% of men will be larger than that dummy. The second dummy is a 50th percentile male dummy, and the third is a 5th percentile female dummy. So right off the bat, Men are twice as represented as women, 2 dummies to R1, which totally represents sex ratios in the extant human population. Added to this already sort of substantial gender data gap, the female dummy isn't even used in most of the tests, and she isn't tested at all in the driver's seat because, of course, women don't drive. Okay, I'm going to set gender bias aside for now. I think there's a myriad of other biases that can impact health and wealth. So, for instance, in the US, during the COVID pandemic, when schools switched to online classes, they unintentionally failed to consider access for students in rural communities who either had no computer access or had no internet access. And this was solved over time by providing these students with laptops and satellite internet connections. However, this oversight really left these students at a significant disadvantage to their peers in urban, more affluent communities, as you can imagine. Access or lack of access to community and or product benefits is also an issue. So there's a company called Equivant. It was formerly, I think, called NorthPoint. And it's the company behind this proprietary software that was used to provide detailed algorithmic assistance in judicial decision making. And it's one of the many players in the predictive justice field that's used in the United States today. And there was a report by the Electronic Privacy Information Center that found that algorithms are increasingly used in court to set bail, determine sentences, and even contribute to determinations about guilt or innocence. This shift towards more machine intelligence in courts is allowing AI to really augment human judgment. And as you can imagine, could be extremely beneficial for the judicial system as a whole. However, of course, there was an investigative report by ProPublica that found that these algorithms tend to reinforce racial bias in law enforcement data. Algorithmic assessments tend to falsely flag Black defendants as future criminals at almost twice the rate as white defendants. What's more, the judges who relied on these risk assessments typically did not understand how the scores were being computed. And as you can imagine, this is problematic because machine learning models are only as reliable as the data that they're trained on. If the underlying data is based or biased in any form, there's a risk that structural inequalities and unfair biases are not just replicated, but they're also amplified in the algorithm. In this regard, AI engineers really need to be extremely wary of their blind spots and implicit assumptions. And it isn't just the choice of machine learning techniques that matters, but also the small decisions about finding, organizing, and labeling training data that is used for AI models. As you can imagine, biased data feeds biased algorithms. And it's not just health and wealth that is impacted by bias. Over 30,000 new products are launched annually, and 95% of them fail. Some due to bad data, others due to incorrect assumptions, like the Bic lady pens on the right-hand side. Apparently, somebody felt like women needed their own set of pens for delicate hands. But I think, bad data is just part of it. I think others are due to incorrect assumptions about consumers' product needs and desires. And that's obviously where bad data or biased data can have a real impact as it relates to brands and the products that are developed that so many of us use. Okay, we've spent a fair amount of time so far highlighting the problems created by unconscious bias that drive the development of biased algorithms, as well as the issue of biased data sets that feed into previously unbiased AI code. Now I'd like to sort of spend the second half of the presentation sort of focusing on how we can actually help these issues. And there's lots of ways that we can make things better. We can use AI to eliminate hiring bias. You want to make sure that you're working with complete data sets, obviously. You want to access or create open source environments. ensure that if you do have an AI ethics group in your company, or if you're part of an AI ethics group, that it's a diverse group, so you're getting people with different types of backgrounds. You want to measure and audit, obviously, how your AI is performing. And then to really be aware of trends like algospeak that look to circumvent machine learning in AI. And if you're not familiar with algospeak, it refers to code words or phrases users have adopted in an effort to create a brand safe lexicon that will avoid getting their posts removed or downranked by content moderation systems. So for instance, in many online videos, it's common to say unalive rather than dead, or SA rather than sexual assault, or spicy eggplant instead of a word like vibrator. As the pandemic pushed more people to communicate and express themselves online, algorithmic content moderation systems have had a really unprecedented impact on the words that we choose. And that goes particularly on TikTok, sort of given the rise to a new form of internet-driven Ethiopian language. So earlier internet users used sort of alternative spellings, or I think what's called leet speak, to bypass word filters in chat rooms, image boards, online games, and forums. But algorithmic content moderation systems, which many of you are familiar with, are more pervasive on the modern internet and often end up silencing marginalized communities in important discussions. So for instance, Black and trans users and those from other marginalized communities often use algospeak to discuss the oppression they face, swapping out words like white or racist. Some are too nervous to use the word white at all and simply hold their palm toward the camera to signify white people. The reality is that tech companies have been using automated tools to moderate content for a really long time. While I think it's touted as a sophisticated machine learning, it's often just a list of words that they think are problematic. And as you can imagine, that's also subject to bias. Words that I might think are problematic might not be words that you think are. And so there's a few things I'd like you to just keep in mind and consider as you're sort of thinking about machine learning and AI and how you develop those tools and algorithms. You know, things to consider, diversity of the team. Does your team include people of different ages, nationalities, genders, race and ethnicity, sexual identity and preferences, neurological differences, able versus non-able-bodied, rural versus urban upbringing? And it's extremely hard to develop a team, and particularly a development team, that takes into account all of these differences between some people's lived experiences. And so it's not just enough to have diverse teams. You also have to develop other moderation systems to ensure that your algorithms are developing are unbiased. Now, obviously, for many folks, this is the part of the presentation where they start feeling really overwhelmed because there are a lot of considerations, and if developing diverse teams isn't enough, then really how do you fix it? And so I just highlighted 6 small changes that can actually have a pretty profound impact on the code that you develop. So the first is, to really look at your recruitment practices to make sure those are unbiased and that you're getting diverse team members into your business. You can also expand your network. That helps recruit more diverse developers and folks into your ecosystem, particularly from outside of maybe the traditional networks that you've been using. I think you also have to give people a seat at the table, not just an invitation to the table. So you have to give people a voice and allow them to participate and give their perspective on codes that you're developing. Fourth is obviously to check your own biases. Again, everyone, myself included, has unconscious bias, and it's very important to be aware of where your biases sit and how you can best overcome those. You also want to ensure the systems you're designing aren't discriminatory, obviously. And then practice really radical transparency in your code and measure your progress. It's just incredibly important that we take a critical eye to the types of software and technologies and code frames that we're developing, and to really, sort of set ego aside and make sure that the things that we're building are really unbiased and fit for purpose and built to last. And then I also want to share some key questions for consideration. And I really encourage folks to ask this about any kind of AI algorithm or machine learning algorithm they're developing. So, what might the legal rights of an individual be impinged by our use of data? How might individuals' privacy and autonomy be impinged via our aggregation and linking of data? How do we know that the data is ethically available for its intended use? Have we identified and minimized any biases in the data or in the model? How will any potential model or bias be identified and mitigated? And how transparent does the model need to be, and how is that transparency achieved? These are all super important questions to ask. And then I would say, if you walk away from one thing from this presentation, it would be the resources and talking points on this slide, which is, again, be aware of your own and others' biases. I think data diversity is just as important as team diversity, and that's incredibly important in AI, where your algorithm is actually learning from the data sets that you're utilizing. And then I also think global collaboration on AI ethics is really important. And there's some great resources that you can access. Obviously, the European Commission has guidelines for artificial intelligence for Europe. That's a great starting point. I'm a big fan of the Human Rights Data Analysis Group in the US. There's the Institute for Ethical AI and Machine Learning in the United Kingdom that's doing great work. And then if you're into researching data, like I am, I'm a big data wonk. SMR, which is the big global association that represents the data and insights industry, has a lot of guidelines on the ethical use of AI and data for research purposes. So really helpful resources that I'd encourage you to check out. And then lastly, I just want to leave you with a quote from Albert Einstein, who said, you can't create or I guess solve a problem with the same mindset that created it. So you can't solve a problem with the same mindset that created it. I hope today that I've inspired a mindset shift and prompted you to think about what you can actually do to ensure the AI that you develop is truly ethical.